In this video, we shall talk about a concept called probability generating function, which is generally abbreviated to PGF. It is a tool to deal with distributions of random variables. Not of any random variables, but only of random variables, non-negative integer values. So probability generating function is meaningful only for random variable taking value 0, 1, 2, 3, 4, etc. etc. Suppose the probabilities of these are denoted by P0, P1, etc. where obviously all the Pi's are non-negative and they also add up to 1. So if someone gives you a random variable like this, then we define its PGF as the function xi t, which is P0 plus P1t plus P2t square, etc. So P, whatever the subscript, t to the power that same number. Now this t is a real value variable. So I need to specify what are the possible values of t. It has to be real, but in general it could be an infinite series, in which case not all t's will keep it convergent. So I will define it only for those real values of t for which this sum is convergent. Let us take an example to find out PGF. Suppose x is a random variable which takes only the values 0, 2 and 5 with probabilities half, 1/4 and 1/4. So P0 is half, P1 is 0, P2 is 1/4, P3 and P4 are 0, P5 is 1/4 and all the other P's are equal to 0. So when I said it takes these values, I am not saying that all these Pi's are strictly positive. They are greater than or equal to 0. So x cannot take any value outside the non-negative integers. Now if I just plug it into this formula, then I will get xi t equal to half, that is P0, plus, I do not have this term, so I jump here, 1/4, that is the probability, times, this is for 2, so it is t square. Then I skip these two terms because these are zeros. The fifth term, again it is 1/4, but now it is t to the power 5, and that's it. Now since it's a finite sum, so this always makes sense for all real values of t. So here I will say that the PGF is defined for all t in R. So that was a very simple example where x takes only finitely many values. Now let us take an example where x takes countably infinitely many values. We shall take an example where all these non-negative integer values are taken with strictly positive probabilities. In this case, I am taking probability x equal to k equal to 1/2 to the power k plus 1. So here it takes the value 0 with probability half, then half square, half cube, half to the power 4 and so on. So it's the geometric distribution. And I am interested in finding its PGF. So I will just apply the formula. So the first thing is just half. The next is again half, but t by 2. Again, not half, square. Then it is t cube and it is t square and it goes on like this. So I can write it in this way. I will take the half common and it is 1 plus, then it is t by 2 squared like this. So t by 2 squared, dot dot dot. Now when will this sum converge? This is the geometric series, so I can easily see that this will converge when t by 2, absolute value of that, is strictly less than 1. The sum is half times 1/1 minus t by 2. and that is when t is in the open interval minus 2 to 2, which means t by 2, absolute value of that, is strictly less than 1. Now if I just write it in a slightly different way, this will become 2 minus t. So here is another example of a PGF where I have it defined only over a certain interval of t values. Here is a little example for you to solve. I have given the definition here so that you remember it. The exercise is, if x is given to be a binomial NP distribution, x has this distribution, then find the PGF xi t of x. You should also tell me what are the values of t for which this is defined.